So there are different forms of the quadratic function. We have y is equal to ax squared. Another is y equals ax squared plus k. Next is y is equal to a quantity x minus h squared plus k, or the standard form of the quadratic function, which is y equals ax squared plus bx plus c. Now let's have the first example. Observe the following graphs. What can you say on the opening of the graphs when the quadratic term is positive? Meaning, the value of a in ax squared is positive. Think. What can you say on the opening of graphs when the quadratic term is negative? Ax squared. Like these examples. Think. Okay, let's see if what you think or idea is correct. The effects of changing the values of y in function y equals ax squared is that a indicates the opening of the parabola. If a is positive, then the graph opens upward, while if a is negative, the graph opens downward. Let's have another example using another form. This one. What do you notice about the shape of the graphs of y equals ax squared? Given the equation of the functions, we have green 1/4 x squared, red 1/2 x squared, f of x is equal to x squared, and t of x is equal to 8x squared. What do you think? Okay, let's have another. Keep that in your head. Okay, the effects of the values of a in y is equal to ax squared in the graph, as you see, the larger the absolute value of a is, the narrower the graph. Let's go back. As you see, the value of 8x squared, or the function 8x squared, is narrower, meaning smaller opening, than the graph of the s of x is equal to 1/4 x squared. Meaning, if the value of a becomes greater, the graph is narrower. The value of a in the function becomes a fraction smaller than 1. The graph becomes wider. Okay, let's proceed. How about this one? What do you notice about the shifts in the graph of y equals ax squared plus k? Now we have here the form with the value of k. What can you say about the movement of the values of k in these given functions? Think. Let's see. The effects of changing the values of k in the graph of y equals ax squared plus k is that we slide or we move the graph of the function vertically k units. When we say vertically, we move the graph upwards or downwards. If k is greater than 0, then the movement is upward. If k is less than 0, we move the graph downwards. Let's have another kind. This one. What do you notice about the shifts in the graphs? Using the form y equals a quantity x minus h squared. Observe the 4 different functions. What movement did it do? Did it make? Okay, let's reveal. The effects of changing the values of h in the graph of a function is that we move or slide the graph horizontally. It means if the value of h is greater than 0, we move to the right. While if h is less than 0, we move to the left. How about this one? The given function is in the form of y is equal to a quantity x minus h squared plus k. How are we going to describe the shifts, movements of the following graph of the function? There is an h where the movement is horizontally, and for k, the movement is vertically. Again, the effects of changing the values of a, h, and k in the function y equals a quantity x minus h squared plus k as a vertex form of the equation or the function is that h moves horizontally units and k moves vertically units. Thank you.